All right, we're going to study comparing a numerical and a categorical variable, and we will look at the numerical measures. And so let's go to the raw data, and let's compare. Let's look at the level and the speed. Copy that data and put it on to this numerical measures tab. So we would like all of these summary statistics broken down by level. So the first thing we need is we need the different levels. Now I know them and I could write them down, but a nice feature is to use the unique function. It returns the unique values in a column or in an array. So if we start at A2 and we go down to I believe it's 840, these are all of the unique values, so those are our levels. And so we're going to make a summary table comparing these numerical measures for these different levels. All right, so the first thing we need is the max. Now the maximum value, what's the fastest Major League Baseball pitch? So you don't want to say the maximum of column B because that is for everyone. The maximum is 96. So we want to know the maximum only if we are dealing with Major League Baseball. So we could say, I want the maximum. Okay, but I want the maximum if the logical test. So I want the maximum if, let me click here. What's in that column equals this value, comma. Now what's the value if true? So anytime column A equals the Major League Baseball, I want the maximum of what I want to take column B. So if A equals Major League Baseball, then look at the values in column B and take the max. And we get 96. Now, since I have coded that as D2, I should be able to take it and slide it right down because now we have D3, then D4, and the A and B stay the same. So there's our max. Same thing for min. I tried to copy and paste, it doesn't work because look, if it's going to change everything, I might as well just start from scratch. So we want the min, and we want the min if what's in column A, put the logical test. So if A is equal to this value, comma, we want to know, we want to take the value of speed. So if what's in column A equals what's in D2, we're going to take the speed, we're going to find the min. And we'll do that for, whoops, all of these. So we see that the maximum goes down as the level goes down. The minimum goes down as the level goes down. We also see that the maximum middle schooler is less than the minimum high schooler. And the maximum high schooler is less than the minimum major league player. These are all things that we should expect, but it's nice to see. Okay, so now I'll do the same thing, but I'll do this for the median. Now, you know what I'm going to do? I'm going to fix all of these. Because if I fix them, I can copy and paste, and they're still there, and the only thing that changes is I want the average. And now this is a bit of a problem, because if I do this, whoops, let me see. See, I didn't fix, good. I fixed the D, I did not fix the 2. So as we move down, everything changes down the level, and everything else remains the same. So that's great. These are all messy. Let's make sure that we can like read what we have. Whoops. I'm going to highlight this and just go down to 1 decimal point. Okay, so now I can continue doing that for the 3rd quartile. So here we want the quartile. In the quartile, it's this function. We want the quartile. We're going to copy all that in there, and we want the 1st quartile. So that is 1. And then we can take that and copy all down. I'm sorry, this is the 3rd quartile, so I don't want the 3rd quartile, 1st quartile, I want the 3rd quartile. Where for the 1st quartile, I will put a 1 here. Okay. Now let's look at the median. So I'm going to take, I could take the mean, I can put it here, but we don't want the average, we want the median. And then our range is the max minus the min. And that's all the way down there. And our interquartile range is the range of the middle 50%, so the 3rd quartile minus the 1st quartile. Okay. And then our standard deviation, that's the only thing that we have left. Let me copy and paste this. We want it to be our standard deviation for our sample. And we will take that and bring it down. So what do we see? We see as when spread is measured by standard deviation, the college pitchers are the least consistent. Same thing if it's measured by range. Interquartile range is putting everybody much higher in spread than major league. The middle 50% of the major league pitchers is very consistent. And we have the standard deviation for the major leaguer players. So on average, how do you differ from the mean? We have that being the smallest for the major league pitchers. Okay, so we have now our summary statistics by category that we will be able to use for data analysis.